Hello everyone, I'm Yogesh and welcome to the Flutter Implicit Animations course. I'm sure you all like the apps that are visually good looking and have cool animations in it. These animations provide you, as a user, a rich and fluent experience, something that you enjoy interacting with every time you use the app. Flutter enables you, as a developer, to create animations in your app from simple to very complex ones. This course covers one such way, which is using implicit animations. So prepare yourself to learn and code cool animations in Flutter. Now, this original course was produced in 2021. I have gone through this course to make sure everything is working fine and is up to date. But the core concept still remains the same. The major change in the download material was migrating it to null safety and making the sample app work on multiple platforms that Flutter supports right now. That is Android, iOS, web, Mac, Windows, and Linux. It is important that you read the author note of each episode before watching them to understand the changes. That's it from my side. Next, you will hear Emmanuel taking you through the course.
Animations involve smooth transitions of properties of widgets on our screens. This could be something simple like fading in an element, moving its position, page transitions, or more complex animation sequences. In Flutter, everything is a widget, and Flutter gives us lots of widgets to produce different types of animations. But just before we dive into animations in Flutter, let's understand some animation concepts that would help us as we proceed in this course. Take this crane for example. We want to move it from point A to point B over a period of 1 second. Let's do that now. It instantly jumped from point A to point B, and this is not the desired effect we want. But first, would you call this an animation? Well, yes, it is an animation, but why does it not move smoothly to point B? Why does it jump? The reason is simple. The animation occurred at just 2 points over a period of 1 second, and that is the start point and the end point. These points are called frames, and a frame is just an individual image in an animation. Now, to produce the illusion of animation we are used to, all we need to do is to add more frames in between the start and the end points. These additional frames gives us the illusion of animation, and if you play the animation once more, it should move smoothly to point B. Now you might be wondering why I'm calling animation an illusion, right? Well, it is an illusion simply because all you are seeing are different pictures playing at very fast speed, which makes the eye believe the picture is actually moving. Okay, so how many frames should we produce per second to give a smooth animation? Well, the human eye needs about 24 frames per second to perceive an animation as smooth, and this is what is used in the movie industry. But most modern devices produces 60 frames per second, and some produce up to 120 frames per second. 60 frames per second is the base accepted frames per second for smooth mobile animations, and Flutter handles this pretty well. The production of frames per second is also called frame rate, and it is dependent on the device used. And this number can also be used while debugging to check if your animation is performant. So, animations in Flutter is just a way to rebuild parts of your widget tree in every frame whenever a property changes via setState or some other means. Since everything is a widget in Flutter, Flutter gives us different types of widgets to help us create animations. These widgets produce animations that are grouped under two main groups. Implicit animations, which are created with widgets that hide the complexity of managing and controlling the animation objects. You simply set a target value and the widget handles the animations for you. And explicit animations, which are created with widgets that gives us full control of how we manage the animation. And these types of animations can be further customized since we are handling everything explicitly. In this course, we'll cover implicit animations and explore practical examples and scenarios where they can be used. The sample project for this episode is just a very basic app containing a container and a floating action button. And for the code, we have a size variable in which the container depends on for its width and for its height. The unpressed callback of the floating action button toggles the size variable via setState. This causes the container to rebuild with the updated size whenever the button is clicked. This results in a grow and shrink animation, or would it? Let's click on the floating action button to find out. This process takes the container from 100 to 200 instantly without any animation. But if you followed the earlier explanation, you would understand that an animation occurred, but it just happened with just two frames, the start frame and the end frame. We need a way to animate the container in between those two values. Update your code to the following. We changed the container to an animated container and added the duration of 1000 milliseconds, which equals to 1 second. Note, the duration property is required. Save your work and let's try it out. This time around, the container animates with more frames in between. It did not just go to 200 instantly. Instead, it interpolates through the numbers in between to create the desired grow and shrink animation.